Okay, and welcome back to the desk. It's been a couple of months probably. Been doing a few different things, been a bit sick with hay fever and oh my god, the issues. But my voice is back enough I can do a video, which is great. It's been a month I've been trying to get my voice right. So, okay, this is really interesting. I've been wanting to do this for about 6 months and eventually it didn't leave my mind, and it's a simple setup, but I just didn't get around to doing it. So what we have is a tazer power system set to 0.8 volts, which will make the taser module conduct. It's drawing only 0.78 amps. The outputs I've worked out which is positive and which is negative, so I've put some shrink on that, and I've got them going to 30 kV capacitors. Now these yellow here and this yellow here, that's literally just to connect it. They just run off to there and there. The black one here actually is pretty much the same, but I've got it going off to this end of this fluorescent just to see if anything's happening there. Now the other side, again, I've got that purple to connect, but I've got this to a ground wire. That's ground. Now the interesting thing is them outputs aren't connected. Now you can run these tasers constantly at lower voltages as long as it doesn't exceed the capacitor that's inside it, which is probably around about, I don't know, 5,000 volts or something. If it does, that capacitor, actually it's probably about 10, I'm not sure, maybe 10,000. But if you leave these open normally, it'll exceed the capacitance voltage rating on that capacitor and blow the capacitors. That's basically what happens with these fail. But if you run them under about 1.2 volts, they seem to be able to run without actually being connected. But in this situation, I have it going to this 30 volt cap, this 30,000 volt cap. That one's going to ground and has 2 probes for the voltage, and that's at 42 volts. So they are, that cap's charged independently of having this negative attached to it. So what I thought is actually the truth. Now, I did play around with this before. Just, this before. Don't worry about the copper, it's not doing anything at the moment. Just to see if I raised it up, whether it would change the voltage in that cap there. And you can see it's just a little bit, no big deal, probably not worth writing home about, but there is an effect. I don't know what effect that is, but nothing to write home about, really. Look at these big daddies. I'll be sorting them out later. So, I guess just for this single experiment here, yes, that does that. But let's turn this up to, say, 1.1 volts. Okay, so that's 0.8, 0.9 volts. This is a 600 volt rated. Is it? Yeah, it is 600 volts. Let's just make sure. What does it say? I think they're cat 3. Yep, 600 volts DC. All right, I'm going to go to 1 volt. All right, 1.1 volts, 1.2 volts. Why have I stopped going up? 1.2 volts, 1.1 volt. Okay, 1.2 volts, back to 1.2. Let's get to 200 volts. There we go. So at 1.3 volts, we're drawing just over half an amp, which is 0.76 watts. And I've got 200 volts in that cap. in relation to ground. If I had this output here attached to that cap, that would be probably about 5,000 volts. So what I want to do next is I've got another ground rod outside, but it's about maybe about 8 meters away from the ground. Oh, actually no, that's the other one. 2, 3, maybe 4 meters away from this ground rod, and I haven't got a wire attached to it, so I'll do that tomorrow, and we'll work out if the capacitor charges to the same amount. That's probably a good idea. And then we'll start playing around with a resistance in line. What type of resistance will we use? Actually, yeah, I will play around with that. But what I want to do is I want to put a coil, a flat pancake coil bifilar, and I want to have that in series with this, with a spark gap. So I want that spark gap to be very low, and I'd like it to be a gas discharge tube, but I'm not sure if I'll do that. I'm not sure if they are violent. I don't think they're quite that violent in their brake, and I need that Tesla mentions the violent brake is what is needed to get that rapid collapsing coil. So the secondary coil to that bifilar will be connected to maybe that fluorescent, and so I want to get these both working in the same sort of setup. I want to play around with a bias, so maybe a bit more resistance on one than the other, or a bit more inductance, or a few little things like that. But that's the road I'm going down at the moment. And to see, let's just see if there's any heat in that. Okay, you can probably hear that little whistle. There's no heat in that at all, so that's possible to make that constantly work at probably a full amp. All right, let's go up a bit. All right, so we'll go up to 1.5 volts. You can hear a whistling in it. No heat, and that's not quite 1 amp yet. We're at 1 amp now exactly, actually. It's quite amazing. And that's at 322 volts. So, yeah, it's going to be interesting to see what we can create. I think some of you might know where this is going. If it goes there. If it goes there, great. If it doesn't go there, well, we've got more work to do. Say hello to Don if you see him sometime. See you guys.